All right, everybody. So we're going to start with the position of the sun's altitude questions, number one. So number one says in the diagram below, a vertical post casts shadows A, B, C, and D at four different times during the day. Which shadow was cast when this location was receiving the greatest intensity of insolation? All right. So which of these shadows was cast when this location was receiving the greatest intensity of insolation? So we first have to understand something. What how must the sun be positioned, right, in order for a location to receive the greatest intensity of insolation? Well, in our notes, if we look on page 2, we see that higher sun angles, right, mean more intense sunlight. Okay? Higher sun angles mean more intense sunlight. So that means we have to find which shadow was cast when the sun is in its highest altitude. When the sun is in its highest altitude. All right, keep that in mind. So, what do I know about the shadow, the length of a shadow when it's in its highest altitude? Well, if I look at page 5, they tell me right here, sorry, they tell me the shadow will be the smallest at solar noon when the sun is at its highest point. All right. So the shadow will be the smallest when the sun is at its highest point. So therefore, let's reverse it. When the sun is at its highest point, it will give you the smallest shadow. I will simplify it and say it much more slowly again. When the sun is at its highest point, it will give you the smallest shadow. And that's why the correct answer is choice C. All right, let's take a look at number 2. So number 2 says the diagram below shows the apparent path of the sun for an observer in New York State. So this person has to be in New York State. For this observer, the intensity of insolation is least when the sun is at point blank, right? When they're talking about the intensity of insolation, right? They're talking about how much energy, right? How much energy comes from the sun? How much energy comes from the sun, right? So when the sun is at point blank. So according to our notes, if we go to page 2 of our reference tables, right? It says right here, the lower the sun angle, right here, the lower the sun angle means less intense sunlight. So what does that mean? Lower sun angles mean less intense sunlight. That means, oh, sorry, just removing this stuff out the way. I apologize. That the intensity of insolation is least when the sun is at point D. Why? Because that is when the sun is at its lowest angle. Lowest angle equals low intensity of insolation. All right, number 3. The map represents a part of the Earth's surface and its latitude, longitude coordinates. Points A through F represents locations in this area. Which location would have the greatest angle of insolation on June 21st? Well, we have to ask ourselves, what is the highest angle of insolation that we can have? The highest angle of insolation that we can have is 90 degrees, right? So I got to ask myself, which latitude, right? What latitude receives 90-degree sun rays on June 21st? Well, June 21st is the same as what? June 21st is the same as the summer solstice. So I need to find out which latitude during the summer solstice is going to have the greatest angle, right? Or the highest angle of insolation on June 21st. So when I look at my notes and I look at page 3, during the summer solstice, it says the sun forms a 90-degree angle at noon at 23.5 degrees north. That is our prize latitude, right? So I know 23.5 degrees north, that is when the sun is going to be at the highest angle. So what does that mean for me? Which location would have to have the greatest angle of insolation? It has to be the angle that is closest to 23.5 degrees north. And so 23.5 degrees north, right, is a little less than half, is this entire latitude right here. And out of the options that they've given you, which location is closest to 23.5 degrees north? A, E, C, or F? Well, out of A, E, C, and F, the letter that's closest to the Tropic of Cancer is going to be letter F. So once again, we had to pick a latitude that will receive the greatest amount of insolation on June 21st, which was latitude 23.5 degrees north. The letter that's closest to the latitude, this latitude, is going to be the location that has the highest angle of insolation. All right, number 4. It says the model below represents the apparent path of the sun across the sky on March 21st as seen by an observer on Earth. At which latitude is this observer located? So remember, every special date, the summer solstice, the equinox, and the winter solstice, has a latitude where the sun will be directly over an observer's head at a 90-degree angle. So I see right now that the noon sun is directly over the observer's head, right? And I see that on March 21st, this is also known as the equinox date, right? Fall and spring equinox, right? The same where the sun rises and sets is the same. So which latitude is the observer located? I gotta look at which latitude will the sun be directly over the observer's head, right, during the equinox. And so when I look at my notes, and I'm gonna go to the equinox, and it says right here, during the equinox, the sun rays form a 90-degree angle at noon at the equator, latitude of 0 degrees. So therefore, my answer is going to be 0 degrees. All right, so it says base your answers to questions 5 through 7 on the diagram below and on your knowledge of earth science. The diagram represents the apparent path of the sun as observed from 4 locations A through D on Earth's surface on the same date. So this is representing the same date. The present positions of the sun represent the same time of day at each location. So where the sun is located at all these locations represents the same time of day. The zenith, the position directly overhead, is shown for an observer at each location. Diagrams are not drawn to scale. And it says, what is the approximate time of day represented at each location? Okay. So we can pick any location in order for me to work on this question. So I can do, let's do location B. All right, let's do location B. All right. And so at location B, what do we know? We know that when the sun is at its highest point right here, what time is it? We call this solar noon or 12 p.m.
Mine describes
All
right.
right. So therefore, hold on. Yeah, sorry about that. So therefore, when the sun is at this position right here, it's 12 p.m., right? So I know that look where the sun currently is. We know that the sunrise occurs on the east side. It reached 12 p.m. and now the sun is on its way back down. That means this time period has to be later than 12 p.m. So what can I cross out? I can cross out 6 a.m. I could even cross out 9 a.m. All right. Now I have to see if it's 3 p.m. or 6 p.m. You know what's interesting about this date? Anytime that the sun rises directly east and sets, I'm going to zoom into this, and sets directly west, the fact that the sun rises directly east and sets directly west, what does that let me know? This lets me know that this is an equinox date. Agreed? This date is the equinox. And what do I know about the equinox? All locations will experience 12 hours of daylight, right? So that means that it could be, right, 6 a.m. to 6 p.m., 12 hours of daylight. So therefore, if this location is 12 p.m. and it represents half the cycle, then that means my starting point right here should be 6 a.m. And if the sun is up from 6 a.m. to 6 p.m., that means that at sunset, when the sun is right here, this should also be 6 p.m. But is the sun at sunset? No, it's not. So that means it will not be 6 p.m. So it has to be a time that is later than 12, but less than 6 p.m. And that's why the correct answer is 3 p.m. All right, number 6. We're looking at number 6. Number 6 says, during the course of the day, which location had the greatest intensity of insolation at solar noon? So once again, we're seeing greatest intensity of insolation, right? Intensity of insolation talks about the amount of energy that comes from the sun. So which location had the greatest amount of energy that comes from the sun, right? So when I look at my notes, when we look at page 2, right, you can do this as well. If you go to page 2, and you see it says right here, higher sun angles means more intense sunlight. So the higher the sun angle, the more intensity, right, that the sun that of the amount of energy that's given from the sun. So when I hear that, I'm basically going to choose which location had the greatest intensity of insolation at solar noon. What time is solar noon? 12 p.m. So at 12 p.m., which location had the highest sun's angle? Which location had the highest sun's altitude at solar noon? And so solar noon is right here. Solar noon would be right here for location D. Solar noon is right here when the path reaches the maximum height. And solar noon would be right here when the path reaches the maximum height, right? Solar noon. Solar noon. All right. And so when I'm looking, the path that when the sun reaches its highest height, right, right at the zenith, is going to be location C. That's when the sun reaches its highest altitude at solar noon, which will be choice C. All right, number 7. Based on the sun's impaired path, where is location D? Well, interesting enough, right, where we saw that all sides show the south compass direction, right? When we did a lab, we actually saw a latitude, right? That represented the same way. So keep in mind, oops, where it is, here we go. Keep in mind, because the sun, right, is rising directly east and setting directly west, we know this is an equinox date, right? And the background information tells us that the preset position of the suns represent the same time of day at each location, and it represents the same date. So this was this website that we used, and when I go to look, and I'm looking to see which, let me uncheck some of these. All right, let me uncheck some of these. There we go. All right. So sorry, give me a second. Here we go. So when I'm looking, there's only one latitude that mimics the diagram. As you see, I'm raising it to 90 degrees north. And as you can see, right, we are in the North Pole. So therefore, the correct answer is going to be, oops, sorry. Correct answer is going to be choice 4. All right, number 8, basic answers to questions 8 through 10 on the diagram below, which shows a model of the apparent path and position of the sun in relation to an observer at 4 different locations, A, B, C, and D on Earth's surface, on the dates indicated. The zenith and the actual position of the sun in the model at the time of the observers are shown. The zenith is the point directly over the observer. From sunrise to sunset at location B, the length of the observer's shadow will do what? Well, when we look, one of the things we got to see, we look at page, let me see, I think it's page 5 of the review. Yep. And it says right here that the shadow will be the longest during sunrise and sunset when the sun is at its lowest point, and the shadow would be the smallest at solar noon when the sun is at its highest point. So that lets me know the higher the sun's altitude, the longer shorter the shadow. All right. So therefore, when I look at location B and I zoom in, then therefore, what we see, right? The sun starts at sunrise. So it starts here, which means my shadow is going to be long. Then as it rises, my shadow decreases to the solar noon where it's going to be short. And then as its altitude descends, its shadow is going to be long again. So from sunrise to sunset at location B, the length of the shadow will first increase. Sorry, it would first decrease, then increase. Number 9 is the same question as number 7. Where on Earth's surface is the observer at location C located? When we see that the sun is traveling in a path where all directions are south, and we did a lab on this, it's also showing that we are at the North Pole. You see 9 degrees north right here? We're at the North Pole. So the correct answer, the correct answer is going to be the North Pole. All right, number 10. It says the diagram below represents the horizon and the sun's apparent path A, B, and C on 3 different dates, as viewed from the same location in New York State. What are the dates of the sun's apparent path? Hold on. Sorry. What are the dates of the sun's apparent path of A, B, and C? So, on 3 different dates as viewed from the sun in the same location. Well, we know when the sun travels its highest path, right? That represents the first day of summer. All right, it's the first day of summer, which means it is the summer solstice. All right. We know that when the sun travels its lowest path, C, we know that it is the winter solstice, right? And we know that at B, in between the summer solstice and the winter solstice, is going to be the equinox, right? So at A, what date is the summer solstice? June 21st. B, what date is the equinox? Remember, the equinox has 2 dates, right? The equinox has 2 dates. Let me just zoom in so I can write it down. So B is going to be March 21st, right? Or sometimes it could be the 22nd or the 23rd. And September 21st or 22nd or 23rd. And the winter solstice is going to be for C, December 21st, or it can be the 22nd. And so when we take a look, the choice that has matches all these, A with June 21st, B with March 21st, or September 21st, and C with December 21st, that ends up being choice D. Remember, when the sun travels, the highest path is going to be the summer solstice. When the sun travels, the lowest path is going to be the winter solstice. And you can find this information at page 7, right here on our notes. All right, number 11, it says use the diagram to answer questions 11 and 12. The diagram below represents a plastic hemisphere upon which lines have been drawn to show the apparent paths of the sun at a location in New York State on the first day of each season. Letter A through I represents points on the path. Which point represents the sunset location on the first day of summer? All right. Well, we know the path that has the highest, right, where the sun travels the highest, is going to be the summer solstice, the first day of summer. And the fact that we know that it's sunset, right, that means it's when the sun is going back down, which is where I is right here. if north is located here and south is here, east is going to be to the right of north, and west is going to be to the left of north. So therefore, sunset happens right between north and west, which would be location I. Another way of knowing this, is where it says right here on page 6, the sun rises northeast and sets northwest on June 21st, which is the summer solstice. So remember, these dates you do have to memorize sunrise and sunsets on these dates. Which point represents the sunrise location on the first day of winter? Well, if the highest path represents the summer solstice, then the lowest path represents the winter solstice. All right, let me just cross this out. All right, let me cross this out right here. So then, therefore, right, sunrise happens towards the east side. So if the winter solstice is DAG, right, DAG, that path, then sunrise occurs at path location D. And to help us to remember, as we said in our notes, the winter solstice, the sun rises, you can see it right here. The sun rises southeast and sets southwest. So the sun rises southeast between south and east and sets southwest. So that's why D is the correct answer. That's pretty much it. All right. Just make sure to like, share, and subscribe, and I'll see you next time. Take care. God bless.